I'm Simon, today's host.
And I'm George, the co-host, and we have our cameraman Raleigh here. Today we're going to be making brownies.
Baking brownies is a chemical change because the molecular structure of the ingredients is affecting and changing each other.
First, we need our ingredients. We need brownie mix, which has sugar, flour, and other things. We need a 1/4 cup of water, a 1/2 cup of vegetable oil, and 1 egg.
We will also need a bowl to mix the batter, a stirring utensil, and something to pour the batter into, like this glass pan and an oven. Our first step is to preheat the oven at 325 degrees Fahrenheit. Then, we need to put a little cooking spray onto the pan so that the brownies don't stick.
While the oven is heating up, we need to make the batter. In a large bowl, we place our 1/4 cup of water, which is a compound, our vegetable oil, which is a homogeneous mixture, and our egg, which is a heterogeneous mixture. Beating the egg inside the bowl can be considered a physical change because we're not messing with the molecular structure, we're just simply breaking it apart, and none of these ingredients are reacting yet. Now, the oil is considered hydrophobic as it repels water, and our brownie mix can be considered hydrophilic because the flour and sugar in the mix absorb the water. This mix also includes chocolate chips.
So now, we stir our batter until it is fully mixed. Then we add our brownie mix and blend it in. Mixing the brownie mix in is a chemical change because the mixtures and compounds in the bowl are changing each other's molecular structures. The batter itself acts like a liquid, but it's made of both liquids and solids. Once we have mixed our batter, we pour it into our prepared pan. Now, the amount of time we need to cook our brownies depends on the pan's material and size. This is because different materials have different heat capacities. Our pan is made of glass, which has a specific heat capacity of around 0.2 calories per gram. The brownie box says that for a glass pan, we need to cook our brownies for around 45 to 50 minutes.
A metal pan, on the other hand, only needs 40 to 45 minutes. The reason why glass takes a little longer to cook is because it has a higher specific heat capacity than metal, meaning it takes more energy to heat it up.
Once the oven is ready, we can put the brownies in and set a timer for the correct amount of time, which in our case is 15 minutes. There are all kinds of physical and chemical changes occurring during the process of making brownies, like blending brownie mix into the eggs, water, and oil. The brownies rising in the oven is considered a chemical change. This is because when heat is applied to the batter, the mixtures inside react and release gases which fluff up the brownies.
Yep, and there are also air bubbles which form when beating the egg that try to escape the brownies. This is why it is important not to overbeat the eggs when we're making the batter, because we don't want to break apart those little air bubbles.
Inside the brownies, the chocolate chips are melting, meaning they go from a solid to a liquid. This is a phase change, meaning it is also a physical change.
There's a lot of thermal energy moving around in the oven right now. This oven is a convection oven, basically meaning it transfers heat through the air. Energy is leaving the heating elements inside and causing the air molecules in the oven to speed up. This hot air rises to the top of the oven and is absorbed into the pan. By conduction, which is by touch, the pan transfers that energy to the brownie batter.
Once our timer goes off, we can take the brownies out of the oven and set them aside to cool. While the brownies are cooling, all the molecules in the brownies and the pan start to slow back down.
Now that our brownies are cool, we can cut them. Now, cutting brownies can be considered a physical change because we're not changing their molecular structure at all. We're simply physically separating chunks of molecules. Yeah. So we'll start right here. Just gonna. Ooh. These are gonna be uneven.
It's fine.
There we go. Using a butter knife. Boom!
Yeah.
2 for each of us.
Yep, because there's 6 people here.
It said 2 for each of us.
Oh, I thought you said
Do
one.
math. Come on.
Shut up! This is not gonna-
On the count of 3.
Hey, it's like a birthday. Wait. Okay.
Now a word from our sponsor. Just kidding, this is the credits. This video is directed mainly by me, George, and hosted by Simon and I, and then written by Simon and I. And we also are very grateful to Raleigh for recording this video. Research was done by all of us, and thank you to Simon for his kitchen.